both Clark's team had, and then got an overtime.
Everybody with me?
More about it.
Gentlemen, we're good? Okay, 11.3, perimeter and area of similar figures. First things we need to talk about is what similar means. We did this several chapters ago where we made similar figures using an ordinary object like soup cans, and I saw rulers and all sorts of things. We used something basic, we either scaled it up or down using similar figures. This is the same idea. So this is the symbol for similar. It's just a wavy line that means similar. And if something is similar, that means the corresponding angles are congruent, the corresponding sides are proportional. We've already dealt with this before, but we're taking this a step further. And this is the basic idea of what we're going to talk about. Two polygons are similar with the lengths of corresponding sides of A to B, then the ratio of their areas is A squared to B squared. Side length ratio and perimeter ratio are the same. That should make common sense because they're both the same dimensions. It's 2 dimensions. I should say 1 dimension. Side ratio is A to B, like a side length. Perimeter ratio A to B, because perimeter is the length around the outside of a figure. Area ratio is 2 dimensions, which means it's A squared to B squared. So if I have this ratio, I can work backwards to find one of these. If I'm given one of these ratios, I can figure out the area ratio using this idea. So using this idea, let's look at my example here. So first thing I want to look at is all the side lengths. When I say corresponding sides, I'm saying in the same spot. So these bases would be corresponding, the heights would be corresponding, either this side or this side, they're both the same, they would be corresponding, and this top base would be corresponding. So let's talk about side length ratios first. So with the side length ratio, I'll get us started. We have 3 to 9. If I simplify that, what does that simplify to? 1/3. 1/3. Let's use my side lengths that are both the same. 5 over 15, what does that simplify to? 1/3. 1/3. How about this bottom? 12 to 36, what does that simplify to? 1/3. 1/3. What about my top base? 8 over 24, what does that simplify to? 1/3. What I want you to see is all the side length ratios are the same. That's what makes it similar. What about the perimeter ratio? What's the perimeter of this trapezoid? Adding all the side lengths up, what do I get? It's 30. What's the perimeter of this trapezoid, adding those side lengths up? And what does this simplify to? 1/3. So this is just one example, but I want you to see that the side length ratios and the perimeter ratios are the same. Let's take this a step further and look at area. So our area formula looks like this. 1/2 times the height times the sum of the bases. Looking at our little one, the bases are the ones that are parallel. So this is base 2, this is base 1, and our height is 3. So when you plug that into my formula, it's 1/2 times the height is 3, and the bases are 12 and 8. What does this give me? Let's do it this way. What's 12 plus 8?
20.
Times 3?
60.
Times 1/2?
30.
There you go. So the area of the little one is 30. Let's do the same thing with the big one. So when I plug this into the same formula, the height for the big one is 9, and the 2 bases are 24 and 36. What does this give me?
60.
270.
No, it's 270.
Oh.
You guys were guessing, don't guess. Okay, let's simplify this. What does this reduce to? 3/27? 1/9. So the area ratios, when they're simplified, is 1/9. Remember what we said over here. The perimeter and the side length ratio are the same. You take that and square it, and that gives you your area ratio. Well, if I take 1/3 and I square it, would that not give me 1/9? It actually would. So I'm showing you one example of why it works and that it does work. So again, the area ratio is the square of either the perimeter or the side length ratio. So keeping that in mind, let's do our table over here. So if I'm given a side length ratio of 2 to 3, what's my perimeter ratio?
2 to 3.
2 to 3. What's my area ratio?
4 to 6.
4 to 9. So what we're doing is taking either of our side length or our perimeter ratio and squaring it. 2 squared is 4, 3 squared is 9. Perimeter ratio of 3 to 5. What's my side length ratio?
3 to 5.
They're exactly the same. What's my area ratio?
9 to 25.
Square this, that gives me 9. Square this, that gives me 25. Area ratio of 36 to 25. What's my perimeter ratio?
6 to 5.
Square root this, you get 6. Square root this, you get 5. And these two are always the
6 to
same.
5.
6 to 5, yep. And when you're doing these kinds of problems, you won't be given any ugly numbers. They'll be easy numbers where you should be able to square them easy or square root them easy. Let's look at the two examples on the front. First one says the polygons are similar, find the unknown area. So now that we know they're similar, we can use the ideas from today. So I have side length that are corresponding, but I don't have anything with the angles. So I can start with 8 to 6. That's the side length ratio. What would be my area ratio? Square this, I get 64.
36.
Square this, I
36.
get 36. When I have given that second number of 9, so this is my perimeter, oh no, I'm sorry, my side length. This is my side length ratio, this is my area ratio. I can use this ratio to figure out the unknown. The first one was my big triangle, the bottom one is my little triangle. The big triangle, I don't know the area. I do know the area of my little triangle. So how do I figure that out? How do I solve a proportion? How do I solve a proportion? Cross multiplier. This is pretty simple. 64 times 9 divided by 36. What does that give me?
All of it? Or the entire
64 times 9 divided by 36.
16?
So this area is 16 centimeters squared. So again, what we did, we were given side length ratios, converted it into area ratios because we had to find the unknown area, and then we used that ratio to compare this area with this area. Put 9 on the bottom because the bottom are my small numbers for my small triangle, top numbers. 64 times 9 divided by 36 gives me 16. For this one's a little bit different. It tells us that this triangle is similar to this triangle, and we're asked to find XY from here to here. Since we're given the two areas, that's what we're going to start with, that ratio. And say 144 over 36. Since this is an area ratio and we need to compare side lengths, how can we figure out those side lengths? Or how can we figure out a side length ratio? Go ahead.
Square root.
Square root. So what is the side length ratio?
12 to 6.
Good. So I can square root. Square root, we get 12 to 6, which simplifies to what? 2 over 1. Remember, if this was just a regular number, we would just say 2. But because it's a ratio, we do have to say 2 to 1. This is a side length ratio. So if we're asked to find 10xy, we're going to put 10 in for my bigger number and figure out what that other number is going to be. So what would that be? What's x? 10 times 1 divided by 2.
5.
It's 5. That makes sense?
Yep.